This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
How's it going, everyone? Welcome back to Father-Offspring Interviews. Our first question today is, why do some people stress eat while others struggle to eat at all when stressed?
A basic dichotomy. There's two types of people. People who during stress eat more, jargon, become hyperphagic, and people who eat less, hypophagic. What's that about? What the studies show is somewhere around two-thirds of people become hypophagic during stress. They eat less. So, where is this coming from? How can we understand the one-third of people who instead eat more than usual, become stress eaters, hyperphagic? Now, one way to look at this is to think about, what does stress do to our behavior? A characteristic of it is, if there is some behavior that we're constraining, that we're trying to do less of, that's taking some self-discipline, this is around the time, because you're stressed, you throw that self-discipline out the window and you do more of this thing you've been reining in. Suppose, for example, you are completely obsessed with conjugating ancient Greek verbs, and you're doing it all the time, and you're ruining your relationships, and you're behind at work, and they're threatening you with your job, and you've managed to get it under control, and you are incredibly proud. It's now been 3 weeks and 2 days since you've conjugated a verb, and along comes the afternoon from hell, incredibly stressful. And what do? You say, screw it, I'm so stressed, I deserve to be able to get a little bit calmer, and you go do whatever you're reining in. So the question becomes, what's going on with individuals who are most reining in food consumption? And to make sense of this, an incredibly elegant piece of wiring in terms of how hormone stuff works. Okay, if you have been awake through more than half of any one of these episodes, you will have heard I inevitably get around to talking about glucocorticoids. Glucocorticoids, stress hormones that come out of your adrenal glands, not adrenaline. Instead, glucocorticoids like cortisol, hydrocortisone, corticosterone, these are at the centerpiece of the stress response. Turns out your adrenals don't just decide on their own when they are going to start secreting stress hormones. What happens instead is something stressful occurs, physical, psychological, whatever, and within about 2 seconds, throughout your brain, you are releasing a neurosignaling, a neurotransmission molecule. You are releasing a neurotransmitter called CRH. Don't worry about what that stands for. And it's doing all sorts of stuff, activating your brain for the stress response. And among other things, what it's also doing is some CRH is getting down, dribbling down from your hypothalamus to your pituitary gland just underneath, which, after about 15 seconds, in response to the CRH, starts secreting the hormone ACTH into your bloodstream, which makes its way to your adrenal glands, such that after about a minute or so, you then begin secreting glucocorticoids. So we've got this hierarchy. First 2 seconds, it's all about CRH. First 15 seconds, CRH, ACTH. Anywhere from 1 minute to 400 years, CRH, ACTH, and glucocorticoids. So the question becomes, what happens when stress ends? Your brain terminates CRH secretion within seconds. Incredibly fast shutoff. ACTH, your pituitary is reasonably fast at it. Within a couple of minutes, it has turned it off. Glucocorticoids take forever to turn off. To give you a sense of this, the half-life, how long it takes to clear half of the glucocorticoids from your bloodstream after you've turned off the stress response, is about 90 minutes. It sticks around for a long, long time. So out of this, we've got this important implication. If CRH levels are elevated and nothing else is, you've been stressed for about 1.5 seconds. If levels of CRH and ACTH and glucocorticoids are all elevated, it means you've been stressed for at least a minute until who knows how long. And what it also means is if you find somebody whose glucocorticoid levels are elevated and ACTH and CRH are pretty much back to normal, that's not during stress, that's during the recovery period. And the critical thing is, even during the recovery period, you're still secreting lots of glucocorticoids. Okay, so this brings us to really the critical question about hyperphagia and hypophagia during stress, which is what kind of stress are we talking about? And let's take two extremes. Let's start off with a single stressful event, and it's 20 seconds long, and it's incredibly arousing in a bad sense of the word, and an acute stressor. And what you see is CRH, ACTH, maybe the first dribbles of glucocorticoids. And under those circumstances, CRH is anorexigenic, which is to say, CRH shuts down your appetite. So, very early in the stress response, it's all about shutting off appetite, hypophagia. Now we're in the middle of the stressor, and what you see, CRH, ACTH, glucocorticoids are all up, and CRH's suppressing of appetite is really strong, overrides anything from these other hormones. So during the stressor, you are still reducing appetite, becoming hypophagic. And then what happens during the recovery period is glucocorticoids stimulate appetite. And suddenly you're doing the opposite. So during stress, appetite's being suppressed. In the recovery period afterward, the exact opposite is happening. Your appetite is being stimulated. So now what we have to do is look at what the scenario is with a single extreme stressor, and you're secreting CRH and the other hormones are beginning to get their shoes on. And what you're doing acutely is turning off appetite. In addition, what's called your sympathetic nervous system is being activated, and it's constricting your gut and decreasing blood flow there, all as part of flight or fight syndrome. So everything is working to shut down digestion and shut down appetite. And this is the picture of anxiety, this sudden brush fire of, among other things, hypophagia. Now we look at chronic stress. Someone says, "Oh my God, I've been stressed nonstop for the last 6 months." So suppose they've had the stress response turned on for the last 6 months. All of the hormones were up after the first 30 seconds. We know what's happening, which is CRH is the strongest. It's going to be turning off appetite. If somebody was secreting CRH nonstop for 6 months, they'd be wasting away with loss of appetite and anorexia. The other thing is they'd be long dead for a million other reasons. What do we mean when we say chronic stress? We do not mean we're turning on the stress response all the time. That's what you do if you have a whole body burn or you're in sepsis or whatever. What we mean when we say, "Oh my God, what a stressful day," is you had a lot of pulses of stressors throughout the day. Someone said something irritating, and then the traffic jam, and then your boss, and then whatever it is. It means you've got a lot of pulses of stress responses. That's typically what's going on when we're saying, "Oh my God, a totally stressful day." So what you see is if this is a pulse, there's a brief pulse of CRH turning off appetite, and then there's a long recovery period of glucocorticoids stimulating appetite. And the question becomes, what's your pattern? How many of these spikes are you getting? And how long does it take to clear the glucocorticoids from your bloodstream? And with sustained chronic stress, we know that actually means a bunch of peaks of stress responses there. You're spending all your time in the recovery period. Glucocorticoids are stimulating appetite. You become hyperphagic. And what is this about? In contrast to the brush fire of a brief singular stressor, this is a picture much more like what you see with depression. This is glucocorticoids having this suffocating effect, where, among other things, it's stimulating appetite. Okay, so this brings in some interesting consequences. When you are secreting a lot of glucocorticoids, and this is a scenario with what we call chronic stress, glucocorticoids do something very, very central to this. There's this hormone that's incredibly famous called leptin. 40 years ago, it was the most famous hormone on earth. It was the disco era's version of GLP-1s like Ozempic. It was the first hormone identified, released by the gut after you've eaten a meal, which suppresses appetite. Oh, that's going to be amazing and huge excitement of synthetic leptins that are going to suppress appetite. And for a bunch of reasons, that didn't work out well. And the excitement now instead is about GLP-1 agonist, GLP-1 mimicking drugs like Ozempic. Any case, you secrete leptin when you've had a meal. And what do glucocorticoids do when they're chronic? They make your brain less responsive to leptin. Whoa, you just had a huge meal. You should be feeling full and sated and stuffed and pigged out. And because of chronic stress, you suppress the satiation signal. And that's one of the mechanisms by which glucocorticoids are increasing food consumption. Then it turns out you are not only eating more, you're eating more of certain types of food. And this was the work of a wonderful neuroendocrinologist pioneer named Mary Dahlman, University of California, San Francisco, who was an old friend and colleague. And she did pioneering work showing that when you are stressed, you crave food, and the food you crave is what we call comfort food. Suddenly you get a craving for high carb, high fat foods. And that's the stuff you eat more of. And what she then showed was if you put a lot of fat and carbs into somebody's bloodstream or diet, it works in the brain to turn off the stress response. Comfort food is comforting. So, what we're seeing here is depending on the type of stressor, if it's a very occasional peak, it's dominated by hypophagia. If it instead is dominated by repeated pulses throughout the day, it's dominated by the glucocorticoid recovery time, the hyperphagia. And glucocorticoids not only suppress satiation, a turning off signal from your gut after a meal, but they're also making you crave the worst foods out there. Okay, so all of this is built around what type of stressor are we talking about? But now we move to the other half of it, which is what type of person are we talking about? What goes into the physiology of do you wind up being someone where CRH is dominating or glucocorticoids are dominating? First question, inevitable question, is there a genetics to it? Yeah, what the studies show is by the rules of the field of behavior genetics, there's a moderate amount of heritability. It's not massive, but it's definitely there, whether or not you are a stress eater or hypophagic. And so a little bit of that is heritable. Some of it involves genes. What genes are involved? Some people may recognize there's a gene for something called the serotonin transporter, which is implicated in everything interesting in the brain. There's a little bit of evidence suggesting what version of this gene for what transporter you have makes you more or less likely to be hyper versus hypophagic during stress. And it is unclear what direction it goes. But part of what goes into deciding whether you are going to be a hyper or hypo is just boring nuts and bolts stuff. How quickly is ACTH carried in your bloodstream? How good is your liver at breaking down glucocorticoids and clearing them out of the circulation? Because that's going to determine how fast the recovery rate is. So part of it, whoa, people who are chronically stressed, and because they have an amazing glucocorticoid clearance rate, they don't get a whole lot of the eat a whole lot to recover from the stressor. On the other hand, if because of genes, if because of developmental stuff, their liver isn't great at getting rid of gluten, it's going to stick around forever. And you get someone who's extremely hyperphagic. By the way, You might be saying, that's weird, evolution, all that stuff. Why did we evolve so that CRH does exactly the opposite of what glucocorticoids do? CRH is all about the earlier phases of the stress response. The early actions of glucocorticoids are about mobilizing energy, dumping it into your bloodstream to hand to the muscles you're going to be using to run away from a predator. And when the stressor is over with, not only do glucocorticoids mobilize energy during the stressor, but as soon as it's over with, they stimulate appetite so you can start building the stores of fat, so on, back up again. Okay, so what's the nuts and bolts individual differences that you have in your body that's going to determine how fast CRH goes up and how fast ACTH clears, and probably most importantly, are glucocorticoid levels coming down like this, or are they staying up for? So that's one of the variables. One of the other variables that's found, people who are stress eaters, people who are hyperphagic during stress, what you see is you sit them down in a brain scanner and you show them an ice cream sundae, and the part of the brain that does anticipation of reward, dopamine parts of the brain, it activates just like somebody who is hypophagic. All you get a hyperphagic stress eater when they've been stressed, and you show them an ice cream cone, you show them an ice cream sundae, and they activate the dopamine system like crazy, far more so than the hypophagic individuals. In other words, stress, however the system is wired up in you as to what responses you have, part of what's going to come is how much are you anticipating food afterward? How much is it weighing on you? How much is it on your mind? Now, of course, what becomes most interesting here is not individual differences and like what your liver enzymes do and stuff like that, but what do we know about individual differences in personality and such as to who becomes a stress eater or stress hypophagic? If you are wired up so that you are somebody who tends to be overweight, elevated BMI, that makes you more likely to be a hyperphagic individual, a stress eater. And what that's often telling us is hyperphagia during stress has almost certainly played a major role in elevating your BMI. So that's one piece of it. But then personality stuff, there's this personality inventory, the big five, looking at five different domains of personality. And you look at people who are stress eaters versus hypophagics, and you look for differences. And where they come through is in this one of the five categories called agreeableness. Agreeableness, people who become stress hyperphagic eaters tend to be low on agreeableness. What's agreeableness about? Empathy, trust, cooperativity, warmth, things of that sort. Does that mean guaranteed that's what you are like if you eat more when you're stressed? And does that mean if that's the personality profile, you're going to be a hyperphagic individual? Just statistically, they tend to go together. Probably the thing that's most interesting as a marker is during stress, do you tend to ruminate in response? Rumination, you sit there moldering and collecting mold, different moldering, and collecting cobwebs because you were just lost in aversive thoughts, negative affect, whatever it is that's bothering you, going around again and again and again. We've talked about the mechanisms for that. That is the profile of people who become stress hyperphagic, stress eaters. And what is that profile about? The rumination is the component of depression most associated with elevated glucocorticoid levels. What your body is doing is preparing you for hibernating as like a bear and storing everything away, and don't move and just sit there lost in your aversive thoughts. And that seems to be the best predictor. People who are hyperphagic during stress, stress eaters, they're more likely to ruminate during stress. So that's what we know at this point. And basically, what you got, about 2/3 of people decrease eating during stress, very context dependent. And by now we know something about the nuts and bolts, something or other with genes and how good the plumbing is in your liver, and then sorts of personality stuff. Is a stressor a lightning storm for you? Or is a stressor something slowly flooding where you're living and coming up to drown you? If it's more the latter, a more ruminating, depressive picture than an anxious one, that's a predictor that you are going to be hyperphagic during stress.
Now, we have two questions about, very specifically, the work of ornithologist Toshitaka Suzuki. So, Kaz from Canada asks, what could be further discovered about the language of animals, given Professor Suzuki's work on bird grammar and syntax? And Seaman from Norway says, are the studies done on birds and language by Professor Suzuki actually showing that birds have grammar and that one species can understand another's word for hawk?
Who would have guessed two questions the same week where I looked to see if Professor Suzuki, Toshitaka Suzuki, had published some major landmark paper recently he hadn't. Somehow the universe has converged to two people wondering about his fantastic work. Okay, Suzuki is an ornithologist and ethologist at the University of Tokyo, and what he studies is bird social behavior, bird cognition. And to study it, he uses one of the tried and true techniques for people who do stuff like that, what are called playback experiments. You have a whole library of recordings of birds making different vocalizations, different sounds, and you're trying to figure out what they mean to a bird. So you sneak up to a bird with your boombox speaker there and you play one of these short vocalizations and see what happens. See what the bird's response is. Whoa, that's amazing. We've now done this 40 times in a row, and every time it causes the bird to do this, but not that. And then this other vocalization causes it to do that, but not this. And you're beginning to get a very, very rough approximation of this is a word in that bird's vocabulary. This was work pioneered by these two guys, one named Peter Marler, Rockefeller University, one of my professors, and a wonderful guy, and a guy named Mark Kanishi at Caltech, also a wonderful person. They did this cool stuff showing that around the San Francisco Bay Area, you get different dialects of bird song at different places. Okay, so bird song stuff's incredibly cool. And here's Suzuki using playback techniques for studying the species that he studies is called the Japanese great tit, and that's Paris Minor Latin. So people have spent forever arguing about what things are universal to human language and what things are unique to human language. And what Suzuki's work, along with a lot of primate work, has been doing is undoing some of those humans are the only species that does X. And the first domain that he's been exploring is what's called semanticity, the meaning of communicative signs. Semanticity, simplifying again, words. Does the species have something resembling words? And there was a great precedent for it that had come out years before studies of vervet monkeys in East Africa. A couple, Dorothy Cheney, Robert Seyfarth, we've mentioned their work, and they found that vervet monkeys have two different types of alarm calls. If you're a vervet monkey, you're up in a tree, and there's two things that are terrifying: snakes on the ground and big predatory eagle things up in the air. And they have the two vocalizations. And what they mean is the snake on the ground one means there's a snake on the ground, run up the tree. And if it's one of the big scary birds up in the sky, run down the tree. And beautiful classic work with playbacks showing that something approximating in vervet monkeys, two different words for very different types of alarms were established there. So Suzuki goes and he shows the exact same thing in his birds. And it turns out they've got two very different vocalizations for scary stuff. For them, one vocalization is, oh my God, there's a snake around. Once again, the snakes. And the other is, oh my God, there's a predatory bird, some sort of corvid thing, or a martin. This confused me a great deal because the paper I was reading had been translated from a Japanese journal, and Martin, Marten, or Martin. Martin is a type of bird. Marten is this weaselly ferret sort of thing. And it turns out it's the weaselly ferret that likes to climb up trees and get into the nest. The Japanese weaselly martin goes up and will kill these birds or eat their eggs. Or so there's two different alarm calls. And rather than go up or go down, the snake one is the all hands on deck. You have the snake vocalization from somebody in one of the trees, and you get out of your nest, get out of the tree, and fly away because the snake's coming. If it's the maybe there's a scary bird or one of these weaselly martins climbing up or whatever, what you do in response is you stick your head out and you look around and you make your decisions based on that thereafter. So a lot like the vervets, but different meanings and different responses, they turn out to have sufficient semanticity that they can have two different words in their language. And again, word metaphorical, language metaphorical. But building on that, now what you then see is, what do these words mean to these birds? Critics weighed in saying this is just like a stimulus response thing, and there's nothing. Are they actually thinking? Are they thinking about martins and trying to remember the spelling of martins and which one they're? Do they actually have an image in their heads of what the scary thing is? So a follow-up study by Suzuki, totally brilliant what he saw, which is you take one of these birds going about their business and you play a snake vocalization, and the bird reacts and flies out and it wants to find out what's going on. And it turns out in this study, if you have put a stick on the ground about a foot long, you're at one end of it, wiggling it back and forth, the bird comes and investigates at a safe distance, pays attention. Is that a snake? What's it? Just leave the stick there, not moving, not interested. Give it any other vocalization, not interested. What a plushy, stuffy there. Instead, not interested. Very specifically, in these birds, you play this snake vocalization. And among other things, they have a cognitive construct of what a snake is in their head. So this was remarkable. This was absolutely great. Next thing he shows, birds have something resembling compound words. Words, you got compound words like horseshoe. You put a horse together with a shoe and you've got a horseshoe. And they are ones where the main thing about this class of words is one half of it means something, the other half means something different. And when you put them together, it means something completely different from that. And humans are good at understanding that. We are good at being able to understand something like that. We are not actually standing, we're not actually underneath something, but put those two together and it means something very different from standing or underneath something. So we do those compound things. What he was then able to show was these birds do the same thing, coupling two of these vocalizations. One was there's something scary around, and the other was fly over my tree. And the same sort of experiments had shown that. And what they showed was you played the vocalization of one bird giving the first call and a completely different bird giving the second call. Note implicit in this, the bird you're studying recognizes individual voices, and that's easy for them. So you play it where you've cut and paste one bird, first syllable, different bird, the second syllable, and the bird does not react as if one bird has said the two halves. It breaks it apart. The bird is sitting there saying, oh, that's interesting. This bird is talking about honey, and that bird is talking about moons, not putting them together. Only when it's coming from the same bird does the study subject react as if the combination has a meaning that is not embedded in each half. Okay, so then he moved over into the realm of syntax, which is grammatical rules. And what humans are great at as a feature of syntax that people who are proud of human communication are always going on about is grammatical rules about sequence. What comes before what? These are the rules that allow us to understand dog bites man, man bites dog are talking about two very different things. So he then does experiments like that. He strings together two or three vocalizations and then a fourth one, which collectively means something. And he shows the birds, and it happened, these were compound ones, so it's doing something interesting and subtle. So he throws them together, and you get this response out of the birds. Now you cut and paste and splice, and you put this one first. Instead of A, B, C, D, you play the bird D, A, B, C, and the bird pays no attention. It knows it's out of sequence. It's sitting there saying, that's bizarre. This person said they're going on a moon, honey. That doesn't make any sense at all. They have word quotes, word ordering in their comprehension. So, what else can they do? At this point, some of his work, rather than focusing on semanticity or syntax, focuses on some of the amazing social stuff these birds can do. Turns out they can do stuff like all sorts of other species do. And we talked about how good dogs, pet dogs, are at eavesdropping on their humans, and they can eavesdrop and learn information from their humans other than direct it right at their face. These birds eavesdrop on other members of their species. If they're having a fight over there, this bird is paying attention. If that one gives an alarm call way off in the distance, this one responds. They're listening to what the other birds are saying. So that's kind of interesting. But then, even more interesting is they eavesdrop on other bird species. Some other bird gives an alarm call, and the bird in this species, the study subject, responds to it. What is Suzuki doing? Obviously, he's now made recordings of all sorts of vocalizations from this neighboring species and plays an alarm call, and the bird reacts. And then he plays an alarm call from a penguin, and the bird doesn't react. It recognizes alarm calls from nearby bird species, which is amazing. And what he then showed was you put a bunch of both species together and you put up a speaker that gives out the alarm call for one of the species, and all the birds of both species mob over this thing. Wow, they know each other's word for alarm. So you can see this is very adaptive, learning some other species communication for something very emergency related. This reminds me of this joke. You've got this mouse mother and her child, and suddenly a cat appears, and they run to try to get away from the cat, and the cat corners them, and he's about to eat them. And suddenly the mouse mother says, "Arf," barks at the cat, and the cat runs away. And then the mouse mother turns to her kids and says, you see the advantages of learning a second language. They got something resembling this here. So now you begin to dissect the fact that they could understand another species' alarm call, a closely related species, as it turns out. Two possibilities. The first one is it's the same word in both species, in which case, of course, they're going to recognize it. What is this about? It may be a little bit different with some frills on it or who knows what. The best insight we've gotten into this came from John Travolta in Pulp Fiction when he famously said, a Big Mac is a Big Mac, but those people in France, they call it Le Big Mac. It's basically the same word. So that's a first possibility. The second is it's a word that's not in your language, it's in somebody else's language, but it is so iconic, you understand what it means. You understand sayonara or mazel tov or kaput or hasta la vista or whatever. And what he's now trying to figure out is it the same alarm call in both of these species, or do they simply know, oh, I don't speak the blue-footed whatever, but I know this word of theirs, and that's not good news. Okay, so totally amazing work showing aspects of social communication, subtle social intelligence, syntax, semanticity that nobody thought that birds could do. So incredibly interesting. What I'm waiting for him to study is something you see with the vervet monkeys, one of the most charming, interesting things ever, which is you got vervet monkeys and they're up in the trees, and their rule is the snake alarm, you run up, and the eagle alarm, you run down, or whatever. And somebody gives a snake alarm. Who is it who gives the snake alarm? Some kid. Some kid. And what all the adults understand is kids are not very accurate. They're not very good. Maybe the kid is giving a snake alarm when it's actually supposed to be an eagle alarm. What happens is nobody runs up the tree until one of the adults seconds it. Yeah, 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 that's actually right. They understand developmental psychology. So you look at this whole body of work that Suzuki has done. It's great, really interesting stuff. And just thinking about how the work was done, I assume this was a relatively small subset of birds that he had access to. And what's he doing to them? He's got them sitting around all day. And this guy just keeps telling us there's a snake and there's a martin. And then after a while, he distorts it, saying snake, snake, and then try snook or snuck. And this had to be frazzling these guys. You remember when we were testing Safi's English language comprehension? When he was young, he was just learning to respond to his name. That's my name. And then we would see, okay, say Safi, and he responds to it. And would he respond if we said Sufi? Or how about sofa?
Or if we did a different word, but with the same intonation or excitement, like, ooh, poppy or fridge, or even threw an accent in, Suffy or Sophie or something to like throw him off there.
That's right. We worked him through that and discovered there were occasions where Safi thought he was a Sufi. So that's the body of work that Suzuki has been doing. Final thing, a recent paper. This is a species that is monogamous, males and females bond together, socially monogamous, which is to say they stay together and raise kids together. And there's a special movement that they have, a gesture in these monogamous pairs when they're both on the branch, having just landed back near their nest. And one of them does a wing flutter thing, which apparently means for the other one to go into the nest first after you. They say it means after you is this very chivalrous sort of thing. It struck me it could be just as readily, you go in first because there might be a martin in there. Any case, way smarter, cognitive, communicative stuff than anyone ever imagined. Really elegant work by this guy.
And that concludes today's episode. I'm Offspring Sapolsky, and thanks for your continued support of science and the beard.